studying molecular dynamics. But today, we're going to be talking about the future of space science missions, both manned and purely scientific. As many of you are aware, this week, the Obama administration announced major changes to the role of NASA and to what its primary focus in terms of manned missions will be. And so we're going to talk a little bit about that, but we're also going to talk about how that affects science missions and anything else. So we have David Alexander, Patricia Reiff, and Dr. Johns-Krull, and I'm going to ask them to just briefly introduce themselves, talk briefly about their research, and give brief remarks on how they see the future of manned spaceflight, of space science, and I guess we'll go from there. So please, everyone, just give them a round of applause. Okay, let's get started with whoever wants to start.
Okay. I'm Pat Reiff. I'm the professor in physics and astronomy and the director of the Rice Space Institute. I've been involved in space research since I came to Rice as a graduate student in 1971. I got my PhD analyzing data from Apollo, and I got to spend a lot of time down at JSC getting the analysis for that. But since then, I've been doing really unmanned missions to study the Earth's magnetosphere, the aurora, the solar-wind interaction with the Earth's magnetosphere, and also magnetospheres of other planets, Mercury and Earth, and to a lesser extent other planets. So I'm involved right now in a spacecraft called Cluster, which is 4 spacecraft studying Earth magnetic reconnection. I'm a co-eye on the magnetospheric multi-scale mission that will be launched in late 2012. So it's important to have one mission in progress and one mission in planning. As for the future of space science, I think something that we're going to be talking about. There was a great talk Monday evening that Jerry went to, where we talked about things that can happen in space science. And I think the one piece that I like the best about this change is that the NASA budget is not being reduced. They are putting more money into space science, which is good. They're going to do a lot more emphasis on robotic missions, which of course give you a lot more science for the dollar. But more importantly, I think the thing that I like about the cancellation of Constellation, you hate to say you like cancellation of anything, but the International Space Station is up and running, and yet we were going to abandon it. And this way we can get back some of the investment on the money we put into the space station. And furthermore, it will force us to go international in our next planning for manned space. And I think that's really important. The International Space Station was an international program, but Constellation was not. It was the U.S. acting alone. And I think we really heard that it was a lot of our international partners were concerned about that. They would much rather have us do something that's international, and so it's more affordable. And it's also, more of an international program, which I think it should be.
I'm David Alexander. I'm a professor in physics and astronomy, as you all know, and my specialty is solar physics. Been here for 7 years now. I guess my NASA connections, just since we're talking about space and stuff, I came here from Lockheed Martin, so I've actually been involved pretty much through every stage of the process of designing the science that you would like to do, designing the mission that can do that science, building it, launching it, and working with the data. Pretty much if you've seen a picture of the sun on TV, it came from something that we had a hand in at Lockheed Martin. I was NASA's representative to the European Space Agency last year to talk about their mission, the Solar Orbiter. I'm on the NASA Helios Physics Subcommittee, which is a subcommittee of the NASA Advisory Council. I've been on review panels where we've actually reviewed the later stages of the missions to see if they get the subsequent funding. So I've sort of enjoyed being part of the whole hardware side of it, even though I'm not the kind of person you want to let anywhere near hardware. In terms of the missions that I guess some of the questions are going to address some of this later, so I'll save that for later. But it's a very active program. NASA has changed a lot in the last few years, even while doing the same stuff in our field, physics is called now. And we've done a lot of reshuffling. The biggest problem I see at NASA is how they've really switched over to low risk. I mean, flying, if you've seen the film Armageddon, where Steve Buscemi character basically says we're sitting on a nuclear bomb with so many thousand tons of rocket fuel, what was it he says? With 200,000 moving parts made by the lowest bidder. That is the sort of, that kind of risk was always associated with NASA, and it's gone a little bit, and that affects us more than some other things. We will be launching on Tuesday the Solar Dynamics Observatory, which is the first of the Link with a Star missions, designed specifically to study the solar magnetic field, what it means for the solar interior in terms of helioseismology, and also what it does for the solar atmosphere. Very exciting mission. Should be fantastic. There's a terabyte of data coming down a day from that. In the first week, it will actually provide more data than all of the other missions have done in their lifetime. We don't know how to handle that, but that's an interesting challenge. In terms of the manned program, I think the manned program makes more sense if you're going to go to the moon and beyond. And I would like to see that, but that doesn't happen without a lot of money. And there's a Norm Augustine report that came out fairly recently that basically said that NASA needed $3 billion extra a year to make that happen. $3 billion, if you think of a bailout, is very, very small. But that's not what the politics are, and that's why NASA doesn't have that money. So that might be something to talk about a little bit later.
So my name is Christopher Johns-Krull, and I'm also a professor here in physics and astronomy. I've been here since 2001. I'm really on the astrophysics side. Most of my personal research involves actually ground-based observing in the optical and the infrared, but I also utilize NASA satellites such as the International Ultraviolet Explorer, Hubble Space Telescope. Have some collaborations with people who are doing stuff with Kepler, recent mission that launched. Its primary focus is to look for exoplanets. I had been involved in the past in the development of the RESI satellite mission, a solar mission on the software side. So I certainly have connections to NASA research and NASA space science, but I wouldn't characterize that as my main focus of my research. In terms of what I see coming online in the future, that particularly excites me, the Next Generation Space Telescope, supposedly on schedule for launch in 2014, is one of the big things that's on the horizon for us. As many of you probably are aware, the Hubble Space Telescope was just recently serviced, the last servicing mission, and so I'm involved in a couple of big projects related to instruments that were put in, particularly the cosmic COSS, what this COSS stands for, Cosmic Origin Spectrograph, that's what it stands for. It's an ultraviolet instrument. And that's one of my particular interests in utilizing space platforms is in the ultraviolet and higher energy end of the spectrum, where we just can't do that from the ground. A lot of stuff that's going on JWST is going to be infrared instrumentation that can be done somewhat from the ground. So there is a tension there, particularly when once HST is shut down, we will not have an ultraviolet presence in space at all. And so many of us are concerned about that.
So I have a list of questions here. I'm going to go down. We might repeat some of these topics, but we'll see how we go. In your opinion, what are some of the most exciting recent developments in unmanned missions? How about technologically? Are there any specific advancements that we weren't able to have before that are upcoming? Some of you guys mentioned the Solar Dynamics Observatory and the Next Generation Telescope. What do those things do that we weren't able to do before?
I think in general, I mean, there's some specific things that we're all excited about in our own fields.